Hello everyone, my name is Nikita and I am from the Bodhi Academy. In the last video, we were continuing with the chapter Is Matter Around Us from 9th Standard Science textbook, and today we are going to do the last part of the chapter which is chemical and physical changes and different types of pure substances. Okay, so when we talk about physical and chemical changes, we have also learned about this in our previous classes, that what is a physical change and what is a chemical change. Okay, before going to changes, first look at the physical and the chemical properties. Okay, physical properties are the ones which we can see, okay, or which we can touch, like that. Okay, for example, color, then shape, hardness, rigidity. These are all the physical properties, and chemical properties are the ones which bring about a chemical change in the substance. Chemical properties which cannot be seen, but they are a major important part of the substances. Chemical properties like the melting point, then the boiling point, okay, then the pH of the substance, etc. This becomes the chemical properties. Now these are physical and these are the chemical properties. Now what is a change? A change which brings a change in the physical properties of the matter is called as a physical change, and a change which causes a change in the chemical properties of the matter are called as chemical changes. Okay, so the interconversion, here if you see, look at this example, the interconversion of states, which we have already seen in the previous parts of the lesson, that conversion of water into gaseous form, then conversion of solid into gaseous form, that is interconversion of state. This is a physical change. This is a physical change because the changes occur without a change in the composition and no change in the chemical nature of the substance. So the definition of physical change is that when changes occur which bring about the changes in the physical properties and there is no change in the chemical nature of the substance. Okay, ice, water, okay, ice, water and water vapor all look different, but they display same physical property. They display different physical properties, but chemically they are the same. Okay, so there is no change. For example, if we convert ice to water and then water to vapor, okay, this physically are three different states: solid, liquid and gas, right? They are physically different. Physically they are very different, but chemically what is that? The chemical formula of all this is H2O. Chemically it is water and physically it is very different. So these are physical changes which bring about only a change in the physical state and does not affect the chemical composition. Okay, now talking about the chemical changes. Both water and cooking oil are liquid. Both are having the same physical properties, but their chemical characteristics are different. They differ in the odor. Okay, their chemical characteristics are different. They have different smell, inflammability. Okay, we know that oil burns in air whereas water extinguishes fire. So it is this chemical property that makes oil different from water. Okay, so burning is a chemical change. So now the chemical change brings changes in the chemical properties of the matter and we get a new substance. So a chemical change is called as a chemical reaction. So a physical change it only changes the physical state of the substance and does not bring any change in chemical composition. Example is conversion of ice to water and water to vapor. Okay, and a chemical change it brings about changes in the chemical composition of the substance. Of substance means it changes, when it changes a substance chemically, it is called as a chemical reaction. Okay. So this were physical and chemical changes. Now we will talk about the pure substances. We have seen what are mixtures, different types of mixtures, homogeneous, heterogeneous mixtures, and then there are further classifications under them. Now we will see what are pure substances. On the basis of their chemical composition, substances can be classified into elements and compounds. A pure substance means containing only one type of matter, okay, one type of atoms. Those can be elements or they can be compounds. First we will see what are elements. You need to remember the names of the scientists over here. Robert Boyle, okay. Robert Boyle was the first scientist to use the term element in 1661. Then Antoine Laurent Lavoisier, a French chemist, established an experimentally useful definition of element. Now what is an element? Element is a basic form of matter. Okay, the simplest form of matter. It cannot be broken down further into simpler substances by chemical reactions. Okay, an element is that form of matter, okay, which cannot be further broken down into other substances by chemical reactions. Okay, so it is the simplest form, it is the basic form of matter. Okay, so under pure substances, first we will discuss about the elements. So what are elements? It is the basic form of matter. Basic form of matter which cannot be broken down into simpler substances. Further, okay, now under elements we have metals, we have non-metals, and we have something called as the metalloids. Okay, we all know what are metals, and there are definite properties of the metals which make them different from other elements. Okay, these properties are, they have luster means they are shiny, they have a shiny appearance, they can be silvery gray or golden yellow in color, they are good conductors of heat and electricity, they are ductility is the property because of which metals can be drawn into thin wires. Okay, then they are malleable because of which they can be hammered into thin sheets, and they are sonorous, they make sound. Okay, so this is metal. Examples of metals are gold, silver, copper, iron, sodium, potassium. Mercury is the only metal which is liquid at room temperature. All the other metals are solid. Okay. Okay, so under elements we have metals. Okay, now we'll be talking about the non-metals. Non-metals have opposite, like properties opposite to that of the metals. they display a wide variety of colors. They are poor conductors. They do not conduct heat and electricity, and they are non-lustrous, no, non-sonorous or non-malleable. They cannot be. They do not have a shiny appearance. Do not make noise on ringing sound, and do not cannot be broken down into, cannot be bitten into thin chicks. Okay, so examples of non-metals are hydrogen, oxygen, iodine, carbon, bromine, chlorine, etc. Some elements have intermediate. Okay, so we talked about the non-metals. Now the last class under elements are the metalloids. Some metals, some elements have intermediate properties to that of the metals and the non-metals. Those fall into another group which are called as the metalloids. Okay, examples are boron, silicon, germanium. Okay, examples of metalloids are boron, silicon and germanium. The examples of metalloids is very important. Yes. So under elements we have metals, non-metals and metalloids. So this is what about the elements. Now we will be talking about the compounds. Okay. A compound is composed of two or more elements which are combined with one another in a fixed proportion. Okay. When you combine two elements in a fixed proportion, that gives you a compound. For example, gases like NO2, you combine element nitrogen and oxygen to form NO2, nitrogen dioxide. That is a compound. When you chemically it forms a compound. Okay, so now okay, so chemical compounds are obtained by chemical reactions. They are obtained by chemical reactions. Okay, and the final product, okay, the final product which is obtained, that is the compound form, have completely different properties. Okay, completely the final product which is formed product has different properties than both the elements. Okay, and it is uniform throughout. It has a uniform composition throughout. Okay, so compounds are formed when you chemically combine two elements in, okay, in appropriate proportions, in appropriate proportion or fixed proportions. Okay, and it involves a chemical reaction. The final product has different properties than the two elements, and it has a uniform composition throughout. So these are the properties of the compounds. Now very important is the difference between mixtures and compounds. Mixtures, the elements or compounds just mix together to form a mixture and no new compound is formed. For example, if you just take powder of copper and powder of iron and you just mix it together, okay, you are mixing and keeping it aside, it will be just a mixture and not a compound. So it will have, okay, so if you just take powder of both, it will have a variable composition at the end. Okay, and the mixture shows the properties of the constituents. These two powders will show, if you do some reaction, it will show the properties of copper or either iron, not a different properties. Then the constituents can be separated easily by physical methods. If we want to separate them, if the copper particles are large enough, we can easily separate them. Okay. Second is the compound. In this, new compound is formed when elements react, and there is a chemical reaction involved over here. Okay. Then the composition of the new substance is always fixed. It is not variable like as in the mixture. The new substance has different properties. The new compound which is formed has completely different properties as compared to the products which was used for the reaction, and they can be separated only by chemical or electrochemical reactions. Cannot be separated by any physical methods, only by chemical or electrochemical reactions. So this was about the differences between the mixtures and the compounds. Okay, then here we summarize the entire, you can say entire lesson. Okay, so matter has solid, liquid and gas. Okay, under matter it can be the mixtures or it can be the pure substances. Mixtures do not have a fixed composition. Under mixtures you can have a uniform composition, which is homogeneous mixture, which includes solutions. Okay, or it can be a heterogeneous mixture. So under this you have solutions, and these are suspensions and colloid, which are heterogeneous mixtures. Okay, homogeneous mixtures are sugar in water, salt in water, sulfur in carbon disulfide, water in alcohol. These are all homogeneous solutions. And heterogeneous mixtures are sand and salt, sugar and salt, water in oil. These are all heterogeneous mixtures, and we have seen different methods of their separation over here. We have studied techniques over here, different separation techniques. Then we came to pure substances. Under pure substances we have elements and compounds. Elements which cannot be broken down into simpler substances, for example copper, oxygen, iron, hydrogen. And compounds which are a combination of two elements formed by a chemical reactions, and they have a uniform composition, they have a fixed composition. For example, water, methane, sugar, salt, these are all compounds. Okay, so here we end this chapter, and what is important in this chapter is, first of all, the differences between solutions, suspensions and colloids, then comparison between all of them, and then different separation techniques, their principles, procedures and applications, and difference between the elements and compounds, and then mixtures and compounds, and also different types of elements. So yes, we have finished with this chapter, and in the next video we will be starting with the new chapter. So thank you for watching my video. Please like, share and subscribe to our channel.